at scale. So a little bit about me, super briefly, so you know where a bunch of these lessons are coming from. So until the end of February, I am the VP of Engineering at Stitch Fix. We use technology and data science to revolutionize clothing retail. Who's heard of Stitch Fix in the crowd? Cool, awesome, great. We got an extra customer last night as of, my talking with the speaker dinner, so that's good. Always trying to do my part. Oh, and I'm also modeling it too. Before that, I was sort of a roving CTO as a service, as my friends used to say. I spent about a year and a half talking about these types of things, like how to move fast, how to do things with technology and organization. Before that, I was Director of Engineering at Google for Google App Engine, so that's Google's platform as a service, like Heroku or EngineYard or Cloud Foundry. And then before that, I was Chief Engineer at eBay for about 6.5 years, and I spent a bunch of time working on eBay's search engine infrastructure, some of the lessons from which we'll talk about here. So in all these things, I have learned this. Faster is better. But often we have this question. We're like, well, should we do it fast or should we do it right? In other words, there is a dichotomy between speed and stability. Well, let's find out. Who is familiar with this book? Great. And the lucky 100 of you that will, have John, wherever he is, signing your book copies, 28 minutes from now or whatever, count yourselves lucky. It's a great book. I was happy to be a small part of some of the conversations in here, so great job that all the authors did. So here are some things that are some learnings from that book. High-performing organizations versus low-performing organizations have a huge range in the number of times they are releasing things to production and the number of times they are able to produce value for customers. So multiple deployments per day versus maybe one per month. Also, the cycle time, the lead time between when I commit a piece of code as a developer and when it actually shows up to production, that might be less than an hour or an order of minutes, or it might be as long as 1 week, let's say, in a lower-performing organization. A high-performing organization might be able to recover from a failure in less than an hour versus maybe a day or longer in one of the lower-performing organizations. And then finally, the ability to, the rate at which problems end up in production. So the change failure rate, what's the percentage of time we release something and it goes wrong, is far lower, order of magnitude lower in the higher-performing organizations versus the lower-performing ones. So an interesting thing you might learn, you might notice here, is these things. This part is speed, and this part is stability. So it is not speed or stability. The high-performing organizations, those people that are in that upper, right-hand quadrant of the mythical thing I could show you if I wanted to do a Gartner deal, have both. They have speed and stability. Yeah? The same exact things that allow us to go fast are also those things that allow us to be stable. And, oh, by the way, if we cared more than about just engineering metrics, it turns out that these companies and these organizations are 2.5 times more likely to have things like productivity and market share and profitability. All right, cool. This sounds great. Let's do it. I want to talk about 4 aspects, very little of which, in fact, almost none of which is technology. Like usually I talk about microservices and clouds and all these kinds of things. I will not talk about any of those things. We can talk about that at the break. What I am going to talk about is the organizational and cultural and process side of this. So first I'm going to talk about organizing for speed. Then I'm going to talk about what to build, and in particular, what not to build. Then I'm going to talk about when to build things, and finally, how to build them. Okay? All right. First, we'll talk about organizing for speed. So this has been mentioned, I think, several times already, certainly yesterday in John's opening keynote, but Conway's Law. So, Mel Conway in 1968 made this observation that essentially you ship your org structure, right? The organization of a software organization is reflected directly in its architecture. So more precisely, the design of the system is going to be a reflection of the communication paths within your organization. So if we want to have a modular system where, as we grow larger, individual teams can move quickly and independently and autonomously, we're going to need to have a modular organization. So small independent teams are much more likely to lead to more flexible composable infrastructures, and by contrast, a larger interdependent team is much more likely to lead to a monolith sort of spaghetti code situation. Does this accord with people's intuition and experience? Yeah, nods all around. Cool. What is cool about this, though, and many people much smarter than I have said this, I'll just say it again, is that this is not just a descriptive law, this is also a normative law. Normative, look it up. It means that it's a thing you can do, you can make it happen. So another way to say that, or the way that is more evocative for me, is we can engineer the software system that we want by first engineering the organization. Does it make sense? What do we want the architecture to look like, N months or years from now? Cool. That's what the organization needs to look like now so we can get there. Does it make sense?
Yes.
Cool. All right. What's that organization going to be like? Well, this is how Google works, Amazon works, Netflix works, Stitch Fix works, a bunch of these companies that are in that upper right quadrant. Small service teams. So the wonderful, very evocative metaphor that is credited to Jeff Bezos of Amazon is the 2-pizza team, right? So no team should be larger than can be fed by 2 large pizzas. The fun corollary from my friends at Amazon is that means you actually can't have too many of the younger people because they eat too much pizza. So typically it's going to be 4 to 6 people, and also that team should be full stack. We can talk about whether every engineer on the team should be full stack. That's a conversation we can absolutely have. But certainly within that team boundary, we need all the skill sets, all the disciplines that we need to have to get our job done. So that doesn't mean all the disciplines in life, right? So there's no team, there's certainly no 4 to 6 person team that does design of the silicon, manufacturing the hardware, racking and stacking in the data centers, blah, 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 all the way up 10 levels to the stack to something that shows up in JavaScript. But we can form team boundaries around, I'm producing this user-visible application, so I do need, people that can do user-visible things, and I also need maybe some persistence and some business logic. Does it make sense? Like, we can form these 4 to 6 person teams out of an array of skill sets, or within that team boundary, that all do the job that we want to do. So we made a small team, that's great. What does that team do? Well, great, let's have it do a thing that matters for the business. Let's align the purpose and the focus and the effort of the team toward a particular business domain. So just like we're going to design our technology, we would like to have around this service team a clear, well-defined interface. It does one thing or a set of related things, a small set of related things. It might, as an operational consequence, maintain one service or an application or a set of related services and applications. And the fun corollary for the people that are on that team is it means that the people on the team develop a deep understanding of that particular product or that particular business problem. Does it make sense? What I'm talking about here are product teams, not project teams. Yeah? Cool. And so you ask maybe, well, okay, that's great, Randy, but like as my team, and my organization is growing, well, how do you deal with it, right? Like, what if you have more than 6 people worth of work to do? Well, remember high school biology and cellular mitosis. So you have a team that is, of a certain size, and it has more responsibility, and then just like cells in your body, you split it into 2, and then each of those, pair of cells splits into 2, et cetera, et cetera. Does it make sense? And the legit question, if you've not been in an organization like this, is like, how do you figure out how to find the boundaries? To be honest, that has never been a problem I've had. I've never actually, theoretically one could imagine like, I don't know how to split these 12 people's work into 2 teams of 6. In practice, that has never been a problem. It always seems to naturally subdivide on front end, back end, or like some vertical split where we subdivide the domain. It has always worked that there is a clear seam or set of seams that happens. Does that make sense? So, all right, in this world where we have autonomous teams, what do the leaders do? Well, they do organization design, right? So you figure out as a leader, how can we make it so that 80% or maybe roughly 80%, let's say, of project work can be within one of those team boundaries. So by definition almost, you're not going to get all of it, right? Because by definition, a strategic thing that your company's trying to do is going to cross multiple teams. So I'm not trying to say don't do those projects. I'm trying to say, if you can figure out a way to draw your team boundaries so most of the work happens within the boundary and not cross-team, then you've done a good job. And oh, by the way, this is a lot like designing services too. Yeah? All right, cool. Next, I want to talk about what to build, in particular, what not to build. So a fantastic book, which you must all now go out and read, is the 2003 book called Lean Software Development by Mary and Tom Popovic. It is so prescient. It is unbelievable. I just reread it a week or so ago because I was actually going to go see them in person in Minneapolis, which was great. They're wonderful people. But so many wonderful lessons that are like, they could have written that book in 2018, I'll say that. One of the many very wise things they said is this: building the wrong thing is the biggest waste in software development. Does it make sense? So like there's lots of things that we do that are wasteful and maybe slower than they could be or whatever, but like 100% of the effort that we put into building the wrong thing is waste. Yeah, 100%. So let's figure out how not to do that. So if you take nothing else away from this talk, I would like you to take these 7 words. What problem are you trying to solve? So as I'm sure happens, you will have a business person, a product person, somebody that wants some work, legitimate work from your team. They'll come to you and they'll say something like, hey, Randy, could you guys add this button to do this thing for me? And I would like your response, as I do, your response to be, I will happily add you that button. But first, let's have this conversation. What problem are you trying to solve? Does it make sense? It may well be, like, we're happy to write code. Like, I'm happy to add the button. That might not be the right solution to the problem. So let's think about what might be. So first on, and this, I guess common sense is not that common, like, let's focus on what's important for the business. So let's have that conversation be around what are the business goals we're trying to achieve, and we as engineers will engineer a solution to solve that problem. What is cool is that once you have an understanding of the problem, it might actually not need to be solved with technology. This happens all the time at Stitch Fix, right? We have physical goods, we store them in physical warehouses. A number of times we've been in conversations with the very smart warehouse team, that we serve, and they're like, hey, we want to change the process around in the line to do X or Y or Z. And then we were like, well, I don't know, can you just change the process? They're like, why do we need to change the tool? And like, you have that conversation, right? Or maybe we do think that there's a better way to do it downstream, and the request is, could you automate this new process? Well, have we tried it yet? Oh no, we think it's going to be better. Well, tell you what, why don't we experiment on the new process and like do it manually for a little while and then see if it's good, and then I'll happily automate it after that. Does it make sense? And again, what you're trying to do here is just simply gain a better understanding, more empathy for the business problem that you're trying to solve. And so a wonderful quote that I use here a lot is the former head of research for General Motors, once upon a time the largest auto manufacturer in the world, a problem well stated is a problem half solved. Really true. Does that make sense? All right, cool. So we decided we have to build something, or something needs to be built. Well, maybe we don't have to build it. So this is probably preaching to the converted, but like in 2018, maybe we don't have to build a lot of physical infrastructure. Maybe we could rent it from an Amazon or a Google or a Microsoft or whatever. Stitch Fix has no owned physical infrastructure on the planet other than laptops and some Wi-Fi devices in the warehouses. And by the way, we are more of a unicorn than a horse, I get that, but these things are available to everybody in 2018. Also, if software needs to be written, let's think about maybe doing open source from the beginning, right? Certainly the kinds of technologies that we talk about in this crowd, container orchestration frameworks, open source databases. For us, we do a ton of machine learning. We don't write the models ourselves, like we do stuff on top of that. But there's a ton of open source software out there. And by the way, it's usually actually better than the commercial alternatives. So you absolutely should think about it before you go off and write or pay for something. In 2018, I'm not all that PC always. It's a rough time to be selling software. It's a rough time in the world to sell software if that's your business. But guess what? I love a service. Yeah? If you provide a great software, do it all. Yeah? So at Stitch Fix, we use way more than 50 third-party services for things like logging, monitoring, alerting. Some of the people that are sponsors here are, we're customers of them. Project management, bug tracking, payments, billing. All these things that are not core competencies of our business, we are very happy to leverage as a service and have that be somebody else's business. Does that make sense? Cool. Okay. This is a quip that I like to say. Soon I think it's going to be just as common to run your own data center as to run your own electrical power generation. By the way, when Henry Ford, when they started assembly lines in the turn of the 20th century, the very first thing you would do before starting a factory is like, where am I going to get power? And that's not hook into the grid. That's like, where is there a river? Yeah, that's what you had to do first. We have come a long way, baby, and we still have a long way to go, you know, in computing. Cool. All right. The last thing I want to talk about in terms of building the right thing is iterating to a solution through experimentation. So if we're going to do something major, let's try out something small and see if we can front load the learnings so that we make sure we're on the right path. So, but we're doing some science here when we do an experiment. So let's actually state a hypothesis about what metrics are we going to move, in what direction, and in what magnitude. And also, you have to understand what the baseline is before you do that. Does it make sense? You have to understand what's the current level of that metric before we decide to move forward. Then run a real A/B test with a proper sample, isolate treatment and control groups. If you run experiments in production, no peekies, right? You got to make sure until you've completely done the whole sample before you make real statistically valid conclusions. You do want to very obsessively log and measure the user behavior and the system behavior as you're going along, because if your experiment goes well, it will help you understand why that's true. When your experiment does not go well, it will help you understand why that's true. Yeah? It'll help you design maybe the next experiment and the next. Does that make sense? All right. 2 examples from eBay where we put this into practice. So this was 2010-2011 timeframe when I was still there. What we were doing was introducing the idea of machine learning into the ranking function of eBay search results. So just like Google has PageRank, eBay has a similar ranking function that decides, what result goes in the 1st position, the 10th position, the 100th position, etc. Before we did this work, there was a hand-tuned set of factors basically written by a product manager, and that product manager was a very smart person, so it actually took us a year to beat it, but we'll see what happened. So we did an increment, and our goal was to use hundreds, maybe thousands of factors, beyond what a human could actually put together. So we had a bunch of data scientists. We didn't actually even have that word yet, but we had a bunch of people that knew how to do this stuff. They developed some predictive models around what happens when people queried for things to viewing them on the site, blah, blah, blah. We did a whole bunch of parallel A/B tests on the site, and we kept a control all the way along. We did a full year of sort of steady, incremental improvements. This was a game of inches. And at the end of that year, we generated, with this work alone, a 2% increase in the overall revenue of the eBay Corporation, which was $120 million. That was pretty cool. That was pretty cool. Okay, here we did another thing in parallel. Site speed. So who is shocked to learn that a faster website means people would buy more and use it more? Let the record show nobody is shocked by this idea. You will be surprised how much I had to try to convince the product management people that this was an important thing. But that's another story. That's involves tears and whiskey and beer. Okay, our goal here was to reduce the user experience latency for the search results. Again, we did a similar iterative process. We would implement a potential improvement. We would A/B test it on the site. We would watch the metrics. Many of the things we tried didn't work. Many of them did. Okay, again, a game of inches. There was no one thing that was oh, all of a sudden slow went to fast, but incremental improvements. Again, with this work, another 2% increase in the overall revenue of the company. So again, another $120 million a year. So between these 2 sets of efforts, each of which involved tens of people, it was $250 million. So yeah, that was cool. All right, very proud to, and I'll just say openly, I did very little of this work, that's what the coordinating part, I was coordinating it, but I was very happy, very proud to be involved with all the people that did the actual real work. Cool. When to build things. When to build things is about prioritization. We always have more to do than we have resources to do it, yeah? So raise your hand if you have more than enough resources and people to do everything you've been asked to do. Right, let the record show that no hands went up. Yeah. Scarce resources require prioritization, right? That is almost by definition. I can't do it all, so I have to prioritize what I'm going to do. And this is all about opportunity costs, right? If I decide to do X with my team, I'm implicitly deciding not to do Y. Does that make sense? So all of these decisions that we're making, implicitly or otherwise, are trade-offs. And what we would like to do, and again, common sense is not that common, is we would like to have that prioritization be driven by return on investment. correctly, we should like think about what investment we're going to make into a thing, what return are we going to get, and sort of, you know, sort by that. Cool. The second thing I would like you to take away is these 4 words. Fewer things, more done. It's not great English, but it's evocative. So here's the way most people run projects, and I will say at Stitch Fix, this is the way we were running projects even less than a year ago. So I've got 5 people on my team. Well, all right, I should have 5 parallel projects. Yeah? And let's imagine these are in priority order. So the first one's the top priority, second, third, fourth, fifth. What's wrong with this picture? It's the fifth is getting exactly the same amount of resource as the first. Yeah? It seems very natural. 5 people, 5 projects, all parallel, great. And they all end, you know, ish by the end of, you know, whatever time period you're talking about. Well, a better way to do this with exactly the same number of resources and the exact same priorities is this. What if we put, if it's possible, 2 people on the first priority? I mean, it has to be useful to do that, but let's imagine that 2 people could be productive on first priority. Imagine 2 people could be productive on the second priority, and we'll put put 1 person on the third priority, and then when those 2 pairs are done with priorities 1 and priority 2, then we'll put them on 4 and 5. Does it make sense? So we have achieved, and this is not even assuming that we're going to get improvements in efficiency by doing things all together. That I think is also true. But simply the fact of doing fewer things at the same time, reducing WIP, yeah, which is the lean way to think about it, we've already made our lives better. Why? Because we have delivered the full value of priority 1 and priority 2 earlier than we would otherwise, yeah? We're in New York, time value of money, like compounding interest. We're definitely are in this scenario. We are taking advantage of the idea that we have the option to do the higher priority things first. In fact, that's exactly what higher priority means. Yeah? When I say something is priority 1, like by definition, if there's only one thing I can do, that's the thing I should do. But so few of us, and I'll say openly, me too, so few of us actually run, our teams in that way. Does this sound make sense? People are feeling this good. All right. The other thing, which I don't even show in the diagram because I put it together this morning, was incremental delivery. So an even better way to do that would be deliver not just one thing halfway through the period, but deliver incremental value, a tenth of the way through, like each week or whatever. Does it make sense? Like that makes it even better and better and better. Make sense? Cool. And the overall idea here is simply this clever quote. When you solve problem 1, problem 2 gets a promotion. And by the way, if anybody knows I've Googled around a lot. Like I didn't make this up, but I heard it somewhere, and I would love to find the reference. If anybody knows that, I'd love to hear it. But I've Googled quite a bit and haven't been able to find it. Anyway, cool. All right. So that is when to build things. The last section I want to talk about here is how to build them. So one of the things that I feel really strongly about in the 27, 28 years, gosh, that I've been in the industry, is that we should really move quality to the left. Yeah? That's something that comes out of Toyota and out of Lean. That has absolutely been my experience. The way I like to think about it, and again, riffing on a little bit this priority idea, is I like to think about quality and reliability as sort of priority 0 features. Yeah? They are equally as important as cool product features or a beautiful user interface. Why? If the site isn't up, it doesn't matter how pretty it is. Yeah? If the site is not up, it does not matter how pretty it is. Okay, cool. All these things are important, of course. But some are more important than others. All right. As a consequence, the way, and again, riffing on the way to form teams, I like to have the same team, the same set of developers responsible not just for the features of the product that they're building, but also for the quality of it, for the performance of it, for the reliability of it, for the management of it. That's a way of having that small 2-pizza full-stack team be able to be productive and have tight feedback loops within there and be able to produce that quality, right? The easiest way to produce high-quality production software is to have it be written with high quality in the beginning. Does it make sense? And catch bugs earlier, fail faster. All right, cool. So a technique that we use, and it's certainly not unique to Stitch Fix, but we absolutely use it very religiously, is test-driven development, right? So what we do is, you're probably familiar with this idea, is that as part of writing a thing, we write the test to make sure that thing is correct. And why do we do that? We do not do that because we want to be slower. That is not our goal. We do it because we want to be faster. Why does it make you faster, Randy, when you're doing more work? Is it faster to run on quicksand or on solid ground? Solid ground. Let the laughter hopefully show that that's what people like. No, it's much faster to run on solid ground. And what is solid about software? It's like highly tested stuff, right? So I want to make sure that the things that I built last week, I know are going to keep working and won't break, when I do my thing this week. Does it make sense? So tests, why do I do this? Tests make better code. A, because I know the stuff that I built last week is solid, but B, now I have the confidence to completely blow up and rewrite that last thing, because I know that if I make a mistake or I screw something up, that the tests are going to catch it. Does it make sense? The tests have my back. They allow me to be courageous in that way. Tests make better systems because, again, it allows us to catch bugs earlier. It allows us to fail faster. So that feedback loop, that third way of DevOps, that type of feedback loop happens earlier. So Microsoft did a great survey of what developers actually do all day I think way back in 2006. So interestingly, this is probably not what you expect, but it accords more than you would think maybe with my own intuition, if I have to really be honest about it, is we actually spend the vast majority of our time reading and understanding existing code and then modifying existing code, maybe if we're in a good situation to refactor it to get ready to do our thing, but really we only spend 5% of our time writing new code. And this, these numbers are going to be different based on where you are in the life cycle of your company, but the vast majority of developers are kind of in this situation. So the investment that we would make, and it is an investment, in test-driven development helps with both of these. Yeah? It helps with the reading and understanding existing code because the tests are executable documentation for how that's supposed to work. Yeah? And also, it super helps when I'm modifying existing code. Right? I go in there and that looks stupid, I'm going to tear that thing out. And did it break anything? Oh no, good, all right, then that wasn't, a useful thing. It actually also helps with the writing new code, but I think the point is made. It certainly helps, at minimum it helps a lot, and very obviously with the 95% case. Does that make sense? Cool. All right, who has heard this? We don't have time to do it right. Here's what you get to say. Do you have time to do it twice? That's a choice. That's a choice. That is really a choice. And I assert, and this is from experience, I used to have hair once upon a time, the more constrained that you are in time and resources, actually the more important it is to build it right the first time. Why? Because we just do not have time to go back and fix that last thing that we didn't finish. Does that make sense? So I would like, and from a user's perspective also, I would like to build one great thing rather than two half-finished things. And I want to be very clear. When I say right, I don't mean perfect. I mean the MVP style. Build just what you need, minimally, viably, and then move on to the next thing. So we do this at Stitch Fix, and the consequence that it has for our development process is we basically don't have a bug tracking system. So we are not magical software developers. We are just as wonderful and terrible as everybody everywhere, believe me. But because of our process and because of our strong belief in and practice of test-driven development, when bugs come up, we just fix them. Yeah? So we don't have this long, we do absolutely have a backlog, and we do absolutely produce bugs. So the vast majority of those bugs are noticed and fixed before they ever make it to a customer. So that's cool. When they do make it to a customer, they are small enough in number that we just fix them right away. Does it make sense? So that backlog, which we totally have, is not a list of all the 1,000 broken things that we're never going to get around to fixing, let's be honest. It is a list of features we want to build and technical debt, which we absolutely have, that we took openly and transparently and intentionally that we ultimately want to repay. Does it make sense? Cool. All right. So we talked about organizing for speed. We talked about what to build and what not to build. We talked about when to build things. And finally, we talked about how to build them. And I will, again, remind you, faster